usprofessionalvmware.com vBrownbag. Tonight we have part 2 of the Cisco CCNA Routing and Switching series with Scott McDermott. You can find Scott on Twitter at ScottM32768. A few show notes before we get started, if I can use Google's PowerPoint, whatever. Questions, drop them on Twitter at vBrownbag or the vBrownbag hashtag, and we'll get them answered either by myself or I'll interrupt Scott. You can view past recordings, upcoming schedules at professionalvmware.com. We have our APAC show every other Thursday, our EMEA shows on Tuesday, which right now are currently running the VCP5 for data center virtualization. They're about to get on to episode 3 or so next week. They just wrapped up episode number 2. We have our Latin America show Thursday nights, our U.S. shows here on Wednesday nights at 7:30, where we're doing the Cisco's certification track just about through VMworld. We've got a couple of virtualizing high-performance applications right before VMworld. You can grab the recordings if you like iTunes for some reason, bit.ly/brownbag-iTunes, or generic RSS feed or podcast player at bit.ly/brownbagpodcast. Again, our guest tonight, Scott McDermott. I'm your host, Jonathan Frappier, so if you have a question and it's on Twitter or in the chat window on GoToMeeting, I will likely be the one answering or at least intercepting. So with that, Scott, why don't you tell us what we got in store for tonight?
Well, tonight we have a couple of follow-ups from the last session, and I'm going to try and hit on some areas that are common sources of confusion for people on the CCNA track, and see if we can't clarify those. And then we'll answer questions as we go along.
Sounds good. I'm going to, if you're ready, I'm going to pass the screen over to you.
Feel free.
Make presenter. Yes, please. And sure. You should have it now.
You should see my screen.
I do. Packetlife.net.
Yeah. So, one of the things that was asked right after the call ended last week, I had this great question about, hey, I've done some of the CCNA prep in the past, and I know it's updated. So it's gone from a version 1 to a version 2. And that was in 2013. And so we've got a slightly different track. So if you had previously done maybe like a Cisco Network Academy class, you may have done the earlier version. And I found this nice article on Cisco Learning Network Cisco Press, that explained what the changes were. And so if you can read my screen, there's some information here. So basically anything that had gone into one of the other tracks. So anything that's in CCNA Wireless or CCNA maybe Data Center, CCNA Security, some of that stuff got removed. So all those so there used to be a little bit about wireless LANs, a little bit about securing the network using the Cisco Security and Device Manager or something like that. I can't remember the name of the tool. But SDN, some of these things, they pulled those out. The RIP routing protocol, because realistically nobody uses that anymore, was pulled out to make time for more in-depth learning about EIGRP and OSPF, which are much more prevalent in the enterprise. And then I've got a list of topics that are added, and really some of these aren't so much truly as added topics as they're sort of updated, or maybe there's additional content to them. So like variable link subnet masking was always in there, but there's a little more content on it. Network address translation and port address translation, a little bit more info on those. Probably the ones that are worth most taking note of is OSPF version 3, so that's configured a little differently than OSPF. and that's used for v6. I think you can actually use it for v4 now, but there was a time when that was the only way to do v6 for OSPF. There's a little bit more emphasis on IPv6 than there had been in previous versions. There's always been a little bit, but this one's, they're starting to ramp it up for obvious reasons. So there's a little bit more about actually making IPv6 work in real networks. NTP, I'm honestly not sure what the Ethernet WAN emulation is. A little bit more troubleshooting. Syslog, the ever popular Cisco licensing is covered in there. So it's just, overall, it's not actually a huge amount of content. Most of what they were doing is they actually were moving things between the ICND1 exams and classes and the ICND2 exams and classes to make them line up a little bit better, because the ICND1 also represents its own certification in the CCNT. So they were kind of trying to even things out and make everything fit with the flow, because you can move from the CCENT to the CCNA, move on up to the CCNP, and then on to the CCIE. So that it's trying to, as time goes on, as you do these different certifications, it builds upon the previous knowledge. So they had to make some adjustments to the courses to make it easier to build upon. So, and if that's that, and actually there's the web page on Cisco Press, and I'm actually going to put together a blog post with a list of a whole bunch of resources for CCNA study. I'll be posting that hopefully later this week on mostlynetworks.com, and I'll include this article in there. Another useful thing that I wanted to point out is there's a site called packetlife.net run by Jeremy Stretch. He's also on Twitter as @packetlife. But he has a variety of really good study materials. The level of detail on the PDFs he's made is probably, for the most part, way beyond what you need, but they're an excellent, excellent reference. So I'm going to pull up one that's relevant, so VLANs.
Hey, Scott, while you're pulling that up, there was a question in about OSPFV3 and how stable it is from Cisco right now.
Oh, I would, yeah, no, totally. It's no issues there. All the routing protocols are hunky-dory at this point. I don't think there's any reason to expect that there would be any problem with that. The OSPFV3 code's been in iOS for many years at this point, so it's not like it's new or untested or anything. So I don't know how many years it's been in there, but it's more than 5 or 6.
Okay.
It's been around for quite a while.
Is it stable for IPv4 as well?
That's a good question. I don't know. I don't see any obvious reason why it wouldn't, but I haven't run that, so I can't guarantee it. But I would that is actually a newer functionality. I think that showed up in some flavor of iOS 15, so that's a more recent thing.
Start combing the knowledge base in the Cisco communities and see if anyone's having problems with it.
Yeah, I haven't heard of any issues, so I'm going to assume not, but we also might have, I suspect that most people are still using V2 for IPv4, and then they've added V3 on top of that, so they're probably running 2 separate ones in many environments. Especially since V6 hasn't really taken off in a big way yet.
Sure.
So,
awesome.
yeah. So, trunks, VLANs, 802.1q, this, for the VMware guys, should at least be somewhat, the concepts familiar, if not the details of exactly how it works. But this is one of Jeremy's, he calls them cheat sheets. And it shows you how the headers are set up. I need a virtual whiteboard because you can't see my hands moving. I'm pointing now. I'll use my mouse. The hands gesticulating wildly. You just have to imagine it. But you can see things like, here's the untagged header, destination MAC header, source MAC address, the rest of the frame there, and then we are interjecting this extra header with AU2.1Q information to identify the VLAN. And just, you know, it gets you down to the header sizes and probably much more level of detail than you need for the CCNA route and switch, but it's got the basic configuration, a lot of really good reference material, and some of it's going to be good study material, but a lot of it is just it's a good reference to have for, you know, setting things up in the real world. Look, here's this whole configuration section. I can't highlight the way I wanted to, but there's this whole configuration section, basic trunk port config. So there's a lot of useful things in these cheat sheets that he has, and they cover physical terminations, iOS versions, all kinds of different things that you may or may not want to know. More information than you probably need. A lot, because he put a lot of those together when he was studying for his CCIE, and then he's kind of added onto that. So, but really good, useful information. Let's see. I also neglected last time to mention the Cisco Learning Network Premium, which I believe is, it's $10 a month. And it's interesting because it has a ton of training materials on it. It's a really good deal. So even if you know, maybe there's just a small subset of videos or something that you want to view, there's a non-trivial amount of content here covering a lot of there's CCNA, route and switch, there's some CCNA security, there's some data center stuff on here as well, I believe. Let's see, there's an index document that tells me, which is all pretty good and useful, but probably more interesting are the Cisco Learning Labs. And so as you see here, we've got this nice network diagram, but if you click on one of the devices, you get a session. And so you can see that I've got a virtual router available, and I can do whatever I could normally do. It's running the iOS and Unix. So, and I believe this is the same stuff that they use, they will probably be using for well, at least for some of the CCIE, they've actually used this for this software anyway for their for the exam. So, I mean, they believe in it pretty significantly. But you can go in there and you can, and the nice thing about this is you actually get, if you type in the correct password, you actually get switches. So we've got some sort of virtual switch here, but then you can do all the layer 2 stuff that you would expect to be able to practice. And so this is the way these are set up, is they have various labs. And this particular lab is you're supposed to go in and configure some access control lists, and it gives you all the information you need, and you can go down and show the steps. But this is actually a really cool and pretty inexpensive way to do some practice and get some more or less hands-on time, because this is as close as you can get to real equipment without actually having real equipment. And it's essentially, it's a cloud lab, you know, so you pay $10 a month and then you can run it as much as you want all month long. Well, not as much as you want, almost as much as you want. You only get like 1,400 hours or something like that worth of running labs, which is more hours than there are in a month. So you should be good to go. But it's a nice way to do it. And then those are running somewhere on the internet, and you actually just telnet directly to that device. So it's not like you have to go through some funny interface or something. So it's actually, it's a really cool thing. And what you telnet to is console port. I don't think they're otherwise accessible, but it's an extremely nifty piece of software that they've made available at a pretty good price, and they have quite a few different labs. Currently there's a video. I haven't really played a lot with this. And then we've got this nice, you do get quite a bit more involved, and you can actually do some real playing with spanning tree. And if you look carefully at this diagram, you'll see that there's they've got this set up with 2 root bridges. can't tell offhand which one's which, but oh, I see what they're doing. So you've got this distribution. One of these, either this DSW or CSW, one of them is the primary route for this set of 1, 3, 11, 63, and 65 VLANs, and then the other one is the secondary route. So they're showing you a nifty trick with, they're running a different instance of spanning tree for each VLAN, and instead of running port channels, so this access switch 1, instead of running like dual connections to there, or maybe a VPC if you had Nexus gear, they're running a connection to this switch and a connection to this distribution switch, and they're totally independent, but what they do is to kind of load balance so you don't just totally lose everything there. They've set up spanning trees so that half of the VLANs go this way and then half of the VLANs go to distribution switch 2. So sort of a way to work around wasting your bandwidth when you're building your high availability configurations. And this is all totally, definitely CCNA level stuff. You might get questions about this. There won't be real difficult questions, but you will definitely get questions about maybe how this kind of thing might get configured, and it's not going to go deep, but this is going to be great hands-on practice for getting ready for those kinds of questions that might come up in the exam, or maybe if it's a simlet. Any questions so far? We'll take that as a no. Wait.
All quiet so far.
Okay. So anyway, a nice tool to have available to you, and it's pretty inexpensive. So the first thing that's sort of a common confusion that I wanted to talk about, and I really needed a graphic. I don't have a graphic. The difference between frames and packets. Actually, I do have a graphic. Sorts. So we're always talking about IP packets. We're sending IP packets between the machines, and maybe we're capturing packets. We're doing things with packets all the time. But until you start studying this stuff, you might not fully grasp the difference between a packet and a frame, because a frame is a layer 2 concept. So we're talking about the pieces of information that are passed between, say, an end device like this PC in the picture and this switch. One moment. I can't just do random things. Oh well. Anyway, maybe I can do that. Ooh, that's not what I want. Okay, never mind. This was a bad idea. I shouldn't have tried to do that. Anyway, so the frame is basically the Ethernet piece. It might also be a serial piece. The serial ports are going to connect to each other with frames. It's going to be a different format, but it's still a frame. That frame essentially encapsulates the IP packet. So when you send so when PC1, which has got an IP here of 192.168.1.2, tries to talk to 192.168.3.2, which is a server over on the right, it's going to send, it's going to take it's going to put an Ethernet, it's going to take the packet, it's going to put it inside that Ethernet frame, and it's going to send it on the wire. And the switch is going to get it, and it's going to say, I don't know where this goes, and it's going to send it onto the router. The information that it uses, the information the switch uses to decide where it's going to go is not the IP address. Layer 2 switch does not care what the IP address is. It doesn't matter to it at all. It's working solely off of MAC addresses. So when you take your PC and you want to send something to maybe it's another PC in its subnet. So, it's got 192.168.1.2, and maybe you're just sending a ping to the default gateway, or you could be trying to talk to another device that's on the 192.168.1 network. So if it's on the same network, all it just does is the PC will actually do an ARP request. And so ARP is sort of like, you can think of it kind of like DNS except for MAC addresses. So what the PC does is it says, I want to talk to this MAC address, or excuse me, I want to talk to this IP address. I know that this IP address, if it's online, has to be on the same wire I am, because it's in the same subnet, and it knows that based on the subnet mask. So when it tries to talk to something 192.168.1.34 or whatever, it says, I know that's on the wire, so it's just going to send its ARP request out, address resolution protocol. It's going to say, hey, what MAC address has 192.168.1.34? And so the device will see that and go, oh, hi, yeah, that's me. I have 192.168.1.34, and my MAC address is, ccc.ccc.ccc. So then once this PC learns that, it's going to put that MAC address in its ARP table, and then in the future, it knows that that's essentially cached, and it knows that when I want to talk to this device, or when I want to send an IP packet to this computer with this IP address, I know that I'm going to send it to this MAC address. Now what starts to get really confusing, because a lot of you probably, at the very least, in working with servers and stuff, you've seen this, you understand at least some of that so far, especially if you've been studying for the CCNA. What commonly gets confusing is when you go to talk to the router, or when you go to try to talk to something outside your area, outside your subnet, sorry, you're going to do the ARP request for the router. When it starts to get really confusing is when you have multiple switches involved. And then you start to do something like, well, it doesn't really get confusing when you have multiple switches involved, but what gets really confusing is when you log into the switch, and then you might start thinking that the switch makes its decisions based on ARP, and the switch doesn't care. It's all based on the MAC address, because it goes through and it learns which MAC addresses are assigned to which ports. If it gets an Ethernet frame for MAC address that doesn't belong to, or that it doesn't know about which port it's on, it just sends it out to all of the ports and waits to see if somebody talks back. If it doesn't, then it just keeps broadcasting it out every time it receives a frame for that MAC address. What gets confusing is when you're managing the switch and you're looking at the ARP table and you're trying to figure out why these two things don't necessarily, why there's no connectivity when the switch knows about this in the ARP table. But the ARP table on the switch is only for the switch's management interface. So you have to remember to keep those separate, because if you start thinking that the ARP table on the switch has something to do with how anything else on the network communicates other than the switch, you get confused. When you're troubleshooting or configuring or doing stuff with the switch, what you really want to do is look at the MAC address table. So get back into this switch. Oops, that's not the password for this switch. Not much here, but this and this, so the ARP table in the device and the MAC address table in the device don't have anything to do with each other. The ARP table is only for the switch's management interface. So don't get those confused and get confused about the fact that when this PC1 over here wants to talk to server 1 over here, it's going to be sending its Ethernet frame to AAAAA, because has to send it through this router interface. And once the router receives the frame, it's actually going to pull the Ethernet frame off, and then it's going to work on just the packet. That's sort of like the difference between an L2 switch and an L3 switch and a router, is the layer 2 switch doesn't care about anything other than the Ethernet headers and the Ethernet frames, or the Ethernet headers in the Ethernet frame. And in the router, or an L3 switch that is actually switching on L3 information, then it actually worries about the IP address and essentially does routing. Even an L3 switch it's a subtle difference, but it's essentially a router. Certainly you can think of it that way.
So Scott, what is it? I'm trying to summarize what you just went over. So
sure.
A frame lives at layer 2 and will be passed around between local switches. As soon as routing gets involved with IP addresses, whatever's doing your routing, whether that's the function of an L3 switch or a separate router, it removes the frame and sends the packets along?
Well, it's going to remove the frame. It's going to make its routing decision based upon the IP headers, and then it's going to put a new frame on it and put it back on the wire.
Great.
Destined for the next MAC address in line.
Great. And then, in this case, in this diagram, R1 rips the frame out that it was passed from the switch, looks at what the IP information determines based on its routing table where it needs to go, puts the frame back around it, sends it over to R2. R2 does the same thing. It removes the frame. Okay, where is this going? Puts the frame back around it and sends it to switch 2.
Yeah. Well, it doesn't. It's not really going to send it to switch 2 per se, but it's going to put it onto that subnet, and then the switch will pass the Ethernet header wherever it needs to. And so this section here that I'm circling, you can't necessarily tell this, the serial link.
The serial link, yep.
Yeah, the serial link's going to get a different header on it. We don't really care from a practical perspective, but it does get a different frame. Different framing ends up on there. And so the thing to really keep in mind, the two things to really keep in mind is that MAC address information is always local to the subnet. It never leaves the subnet. No other subnet ever cares. So if you're, like when you're on your home router and you're talking to it, and then especially when you're doing NAT and everything, nothing other than your home router ever sees your MAC address. So there's no way for anyone else to find out what it is. And then the ARP table on a switch has nothing to do with the decisions that it makes for switching. You have to look at the MAC address table, which is, or the CAM table, but that's its internal, how it's making switching decisions and how it's learned where things are. So you don't want to get those two confused. And then keeping the L2, just making that L2 and L3 differentiation. Any questions, or is everybody good? Okay. Let's see. Actually, I'm gonna make these windows bigger. I have to do that earlier. No. Here it is. Let's do a nice bigger font. That's better. Takes up the whole screen now, but it's much clearer. So, another thing that people get confused on are the wildcard masks. So when we've got a router, maybe it's 10.0.0.1 with the, well, actually, let's just do this. With the subnet mask, we're used to seeing, 10.0.0.1, 255.0.0.0. Actually, we probably aren't used to seeing that. Let's make it more real world. I'm going to just break it down to the ubiquitous /24. So there we go. Now we've got something that we probably see all the time. And then we want to go make an access list for that. And then we get the access list using the network address. And then we do the inversion. What can get confusing is inverting those masks is not, well, at the CCNA level, you don't really care that an inverted mask, the inverted subnet mask can be non-contiguous, but so you could, we could actually do interesting things, like we could say, we could put a 1 there, and we can say, that represents 10.0.0.1 dot anything, because this the actual bits in the wildcard mask represent ignore this bit. So we don't care which bits they are. We can say ignore that bit. So then you can do, you might do something like this. So if all your servers, for example, are on 10.0 and 10.1, then you could actually say, but you're always, maybe they're only on 10.0.0 or 10.1.0. You can say, have this non-contiguous net mask of 0.1.0.255, because then that would represent 10, because it's all zeros, so we're paying attention to all of the bits in that byte. And then the next one, we've got a mask of 1, so it's just that low order bit is going to be paid attention to, or actually, excuse me, it's going to be ignored, and it'll pay attention to all the others. That ends up matching 10.0 and 10.1, and then we want always a 0 and then 255. So you can do some interesting things there. And then the other thing that gets confusing is, so now we've got, this /20 with 240. What do we do? And then it's 15. How do you come up with that? And the quick and easy way to do that is basically whatever your net mask is, you just subtract that from 255. So then, boom, 15. So if we add, and then the other thing that you can do to check is if you have a net mask, so and maybe it's on the exam. Maybe they're giving you, this is the IP address, this is the ACL. Is this going to match, or is this ACL even correct? Something along those lines. You can look at the ACL and you can say, does the ACL and the wildcard mask add to 255? Well, then no, because that's not going to represent the entire subnet. So if we had, something like, we had 63 here, then that's going to represent a much larger group of IP addresses than necessarily the example was really looking for. Maybe more for possibly, yeah. So most of the CCNA stuff should be working on probably some variant of /24, probably with the 255, 255, 255 is 24 bits, broken into some smaller subset of pieces. And that's doing those calculations. So, say we've got the kind of question they might give you on the exam might be, well, we need, starting from the lowest subnet, we need a subnet that can hold 30 hosts, a subnet that can hold 12 hosts, a subnet that can hold, 5 hosts. And then you have to go figure out what the correct group of subnets for that is. And they will probably get, that kind of question would be like a multiple choice. But that's definitely a CCNA style of question. And then you have to go through and figure out, well, let's see, the net mask, so if we take 255 and we subtract 30, then now we're at 225. Actually, does 30 work? I don't think that. So then we need, because actually you need to do, what you need to do is you need to do 30 plus 1, so it'd be 31, because that's going to give you, we can start counting at 0, So that actually, so if you say 31, that actually represents 32. Does that kind of make sense? Because the bits start at 0. Anyway, so it's actually 32 different values. So you take the number of hosts you have, you add 1, you can subtract that from 255. So if we take that off of 255, now we're doing, I hate math, by the way, 220, no, 220, it would be 224. Yeah, so I've been doing this long enough that I never do the math anymore. I just kind of know which ones go with it. And as an aside, there's one of the cheat sheets on the packetlife.net is an entire breakdown of the bit masks for subnet masks and the number of hosts that are involved. So it's just kind of a nifty thing that's useful to have on the wall just to double check to make sure you're doing it right. Anyway, so then we know it's 224, so that's going to make the first segment would be 224. That one's easy, but then you have to realize that your next subnet, because that's going to represent through 10.0.0.31, because that's going to be 31 values. Because we start at 0, 31 is going to be the broadcast. The first, well, yeah, and the first one is just represents the entire network, and we can't use that. So then we know at this point that the next one's going to have to start with 32, and then it's going to have to support 12 hosts, so we don't know what it's going to be because we don't know which net mask we're using yet. So if it's 12 hosts, then we got 13, so now we've got 255 minus 13 is equaling 252, no, 242. But 242, right? Yeah, 242 is not a valid subnet mask value, which I guess we can do that in binary if we have to. So that is 255 in binary, right? So you can always work your way backwards. Whatever way works best for you for doing the math, you can either work your way up or you can work your way down. Math doesn't come real quick for me. I always have to think about it. So I find it easier to work my way down. But however your mind works to get to the correct bit value, just do it. But so we're going to take 1 off. So now it's 254. This one is 2, so now it's 252. And now we're going to take off 4, so we're at 248. So, but we still need to get below the 242 to get to the next thing, so we still have to pull off one more. Did I do that right? That's 240. Yeah, that's right. So that's 240, right? Because our binary, that's 128, 64, 32, and 16, and that's 240. So we can't do a subnet mask less than, or I should say we can't do a subnet mask greater than 242 because then there's not enough room in the subnet for 12 hosts. But so we have to just do the next one greater. So we know that that's going to be 240 is the next one greater. So we know that that's 255.255.255.240 for the next subnet, and that's actually going to give us 1, 2, 4, 8. You add them up, that's going to give us those 16 hosts for that subnet. So now we take the 32, we're actually going to add 15 to it. So we're now at 47. And then you can kind of keep, and then you can just, we could do it again for the 5. So 250. Now, unfortunately, because we took 250, actually it's 255. It's the number of hosts plus 1. So that's actually 200 and 49, and that's not a valid net mask. So this one's going to start at 48, and then 10.0.0.0. So we need to get below 249. So there's 255, 254, 252, 248. So now we know that /21 is going to do it, and so that's actually going to give us eight hosts. So it's, yeah, 8 hosts. So that's going to be 48 plus 7. 56? No, 55. And then that's 255, 255, 248. And this is why everyone hates subnet math. It's not particularly complex, but even if you've been doing it a long time, it's not a real quick and straightforward operation. And in the real world, you can always look it up. But they do, when you're taking the exam, they do give you a, if you've not taken one of these before, they do give you a nice large piece of laminated paper and a whiteboard pen, and you can actually go, well, it's not a whiteboard pen, but it's a style of pen. It's a small pen. Or whatever. Dry erase, thank you, that's the word I was looking for. A dry erase marker, and you can actually go through and figure this stuff out. And
I've got a, I'm typing up a little picture of how to go back and forth between binary and numerical. It was the one thing I was able to teach my wife when she was in college, that her professor didn't say, don't ever talk to your boyfriend again about how to do homework. So I'll tweet that out in a second. Everything else that I showed her how to do that had to do with math, he's like, don't ask your boyfriend again.
Yeah, the binary, it's all pretty straightforward once you get used to it, but it's a pain to do, and it always has been, and it always will be. It's just as we get into V6 and we start dealing with 128-bit addresses, we're just going to look stuff up and memorize things. Fortunately, we don't deal with subnets in the same way with V6. Most V6 subnets end up being a /64, and then you don't worry about it after that. So in some ways it's going to be harder, in some ways it's going to be easier, because we're not trying to conserve IP space as much as we are now. Anyway, that's how I do some of these, and I don't know anybody who actually likes doing it. There may be, I'm sure there's people out there who do, but I don't, and I always have to double check myself and look it up. Not always, but sometimes I have to double check myself, look it up when I'm dealing with more complex scenarios, because in the real world you probably are dealing with larger network segments than these, but and then now with everybody using 10 addresses, everybody's using /24s everywhere, and a lot of that just makes it easier. But this is the kind of stuff that you will need to do for the CCNA exam. When I took it, there were multiple questions dealing with subnetting. I felt like it was a large chunk of the exam, even though the blueprint doesn't seem to indicate it. It feels like a large chunk of the exam is doing subnetting, or at least it was when I took it. Unfortunately, you will find that if you continue on to other Cisco exams, you won't find that subnetting is quite so prevalent. Okay, any questions? Have I bored everyone yet?
I'm trying to convince some people to come off of mute on GoToMeeting, because there's lots of numbers typed in the question window that I'm having trouble stringing together in short pieces.
Yeah. Where is my...
Ray, raise your hand if you want to get unmuted and add some of your math.
Yeah.
I don't know if you've got a good microphone there. I don't see any hands up, so I'd say keep going. We'll get people unmuted if they want to chat.
Yeah, well, and if people have really good ideas, if people have really good questions, let me know, even if you do it afterwards. We're running a contest, which no one has actually entered yet, so your odds of winning are very good.
Excellent.
But
Make sure I have that information so I can put it on the blog post we put up tomorrow.
Yeah, it's until the end of the month. If you tweet a CCNA level question or something at least reasonably close to it, I will try to answer it, and you're supposed to send it to me and include the vBrownbag hashtag. I'm at ScottM32768 on Twitter, and I will try to answer it, and I'm going to put some of these into a blog post later so that everybody can share the knowledge, and the best questions are going to win either a copy of VMware for Networking Administrator or VMware, other way around, Networking for VMware Administrators, or the CCNA library, study library, official certification guide study library, or words roughly to that effect, both courtesy of VMware Press and Cisco Press, which was very nice of them to have.
So a question that just came up, how does the layer 3 VLAN tag work? Is it in a frame or a packet?
There is no such thing as a layer 3 VLAN. There is, VLANs are
layer 2.
Yeah, VLANs are a layer 2 technology. So they are operating at the Ethernet level. It's a virtual LAN, right? So that's representation of Ethernet. And basically it's I think 4 extra bytes added to the standard Ethernet header, and it just has the VLAN number in it. So if it's VLAN 32, it's just 4 extra bytes in there. It says 32, and then when the switch receives that, it knows how to deal with it. If the port is configured as untagged or isn't expecting those packets, or excuse me, those frames, then it's going to take those tagged frames and it's going to throw them on the floor. So that can be very confusing. And the other, yeah, okay, I'll come back to that in a second. But does that help? Did we answer the question there? Or do I need to clarify more?
No, I think that's good.
Okay. Another confusing concept is the native VLAN, often represented as, often considered the default VLAN of 1, which really doesn't have anything to do with it. And at least in Cisco land, other vendors may be doing something slightly different. But in Cisco land, all native really means is untagged. It is possible to have the native VLAN tagged in specific configurations which are out of scope for CCNA, but then it's not really native at that point. But I think like HP ProCurve, they call them untagged, not native. And the switch. So if we pretend, well, if it's so in the diagram here, I'm going to make the diagram bigger. Make it bigger. So if this access switch here is sending a packet, a frame even, that is tagged between these 2 ports, and it is tagged for VLAN 3, then it's got that little extra header on there, and when this distribution switch receives it, it kind of puts its own little internal thing on it. It doesn't use, it's still going to pull the Ethernet frame off. It's going to keep the data, but it's going to pull the Ethernet frame off, and then it's going to put a new one on and send it on to wherever the appropriate port is. What people can sometimes get confused is if, let's say this link between access switch 1 and distribution switch 1 is using VLAN 1 as the native. And then this link between this distribution switch and this core switch is using, maybe it's using, VLAN 32, 12, any other VLAN as the native VLAN. Sometimes people get confused that the untagged frame is going to get here, and then as it passes it on to the next one, it's going to remain untagged, and then it's going to cross VLANs. That's not the way it actually works. When this frame that is on the native VLAN, we'll say it's 1 for this link, the native VLAN comes across. All that means is it doesn't have a tag on it. It's not specifically tagged as some other VLAN. It doesn't matter what the native VLAN is. It can be 1, it can be 32, it can be 4095, or maybe only, no, I think it can only be 4094. But the that part doesn't matter. Once the next switch receives it, it's going to keep internally. It knows which VLAN that data goes on. So it doesn't matter what the native VLAN is for any other link. So if it comes across native to distribution switch 1, and it's on VLAN 1, and it's going to send it on to core switch 1, and the native VLAN on this link is 32, then it's going to put a tag that says this is VLAN 1 on that frame when it goes across. So you can never misconfigure the switches into spanning traffic across VLANs, at least on trunked ports like that. What you can do is, if you need to do that for some reason, is if you have another port that has a native VLAN and you set it up like as an access port, then you can you can trick things into getting across VLANs, but that's not normally what you want to do unless you're dealing with stuff that's not CCNA level, really. So that's another common confusion, is the native VLAN thing. In fact, I was in a CCIE lab prep course at the tail end of last year, and even the people in that class were confused about that. So if you're confused about that, don't worry about it. You're not the only one. Now, one last, I wonder if I can bring this in and edit this image. That would be fantastic. They seem to be turned it off so that I can't do that. That's a bummer. I have technology. I can steal their picture for just a minute here. And I can draw on their picture. Oh, look, another screenshot. It's not the one I want to do. Let's see, this guy. Perfect. So, one other thing that I wanted to mention is spanning tree. Everyone likes to blame spanning tree for creating
Can I whip
loops.
in a quick question before you get to
Yes,
spanning tree?
absolutely.
What's the difference between a native and default VLAN, if there is a difference, or just different terminology?
The default VLAN is 1. So on Cisco switches, they have a default VLAN. All of the ports by default out of the box will be on VLAN 1. VLAN 1 is called default. You can't change that. That's what the default VLAN is. And it is, you could sort of say that it's native. Often people, extremely often, if not usually, people use VLAN 1 as the native VLAN just because it's the default. But the native means untagged. Default VLAN is really just, it's just the default VLAN that Cisco has configured. So if you take a brand new switch out of the box and you plug in a bunch of stuff to it, everything can be on VLAN 1, and as long as they're on the same network, same IP addressing, they'll all be able to talk to each other right out of the box. When you start configuring things, and it gets different. But that's really, default VLAN, native VLAN are two different things, but just because of the way things are configured by default, it can actually be confusing.
Okay, great.
So I'm going to say this guy this isn't exactly correct, but this will work. This really isn't the way you would set up an actual network, but this is the way I'm going to do it for now. So a spanning tree, you've got costs for ports, which don't really matter, actually. And I'm simplifying this greatly because A, we're running out of time, and B, the concept doesn't really matter. Or it doesn't really, it doesn't really matter what that is. And actually what I should do is take one, and I'm going to change the 10, because 10s are good numbers. If I can, gosh. There we go. Okay. So, spanning tree calculates the best path at layer 2, and it's really there to prevent loops. Spanning tree doesn't create loops. It can't create loops. Its point is to prevent loops. What creates bridging loops is spanning tree being misconfigured, or in some cases turned off. Because a couple of important technologies to know are BPDU guard. It's probably the main thing. And actually I should say that really should be over here. And root guard. Okay. So BPDU guard is something that you would normally configure on an access port. And what that will do is if you connect a switch to that port, except for the dirt cheap home switches, which there's nothing you can do about really. But if you connect another switch to this port, so maybe there's a patch panel where there's access to both access switch 1 and access switch 2. If you connect a switch, make a connection between the two of them, if a port has BPDU guard, it's going to detect the BPDU, which is the type of frame that Ethernet switches send out to do spanning tree information. So if you have BPDU guard turned on, then your switch is going to say, hey, there's not supposed to be another switch here. I'm going to disable this port. So that helps prevent loops. And then there's also root guard, which in the case of so when the switch does the spanning tree calculation, so like this guy, whoops, so this guy is doing a spanning tree calculation. He's like, how do I get to this end of the network? He's going to take the path with the lowest cost, and he's going to add his port cost and the port cost of this port. So this isn't actual cost, but this gets the idea across. It's going to say, it's going to cost me 2 to use this link. I have this other link, but this link costs 20, and that's going to be based on speed. So maybe this is a gigabit link, and maybe this is, a 100 meg or 10 meg link. So it's going to choose the lowest cost path. If it has multiple, so if these paths were equal cost, so if this one was also, so if this is 2 points this way and 2 this way, then it needs some way to break even. So then it's going to use this number here, which is representing a priority. The default spanning tree priority is 32,768. Most Cisco switches are using per VLAN spanning tree. And so what it actually does is it adds the VLAN number to the priority, and that's how it actually represents. That's why, because if you go to these priorities, they have to be made in groups of 4,096, because all the low order bits are being used to represent the VLAN. So, VLAN 1, its actual default priority is 32,769, because that extra 1 represents the VLAN number. Well, if you've got 2 switches that are on the VLAN, you probably want to control which one is the root. If nothing else, in a scenario like this where everything's very very even and there's multiple paths that are all equal, then it doesn't really matter too much. But maybe one is a backup path, or maybe the connectivity for the switches is different, or maybe this link down here, with that, boom. Maybe that link down there doesn't actually exist. So for this switch to come down here and then go back up here, maybe that's suboptimal for some reason, or maybe maybe none of this is here. So then if it has to go here and then back up, of course then this is not a good diagram because this doesn't illustrate. Anyway, you want to have control. But when you're using the per VLAN spanning tree, then what you can do is you could say, some VLANs will go to this switch and some VLANs will go to this switch. And then by controlling which one's in charge, the only time anything's going to go the other way is if one of the switches disappears, or if suddenly its cost jumps way up. So that will help. That can help you use the links more effectively, because what's going to happen is, I need my letter back. When the switch is calculating it, it's going to say this is the lowest cost path, and then this tree, the priority numbers are relevant for this. This is the lowest cost path, and what it's going to actually do is it's going to turn that link. Not really going to turn it off, but it's not going to send any traffic down that link. Now maybe there's some reason, and so they'll send everything over this one. If this link goes down for some reason, then the next best pass is this to the DSW2, and then it'll start passing traffic that way. The root guard, maybe there's something about the way the network is built that maybe this is a long path. Maybe it's only, it's down the tree. Or more importantly, maybe someone installs a switch in here, and maybe they have it misconfigured, and it doesn't actually have any connectivity to the rest of the network. You don't want this guy to suddenly decide, if the costs are actually equal. You don't want it to decide that the best path to the root of the network is this one. So if you ever need to do that, then you can use the root guard, because then if it gets a BPDU that has a higher priority than its other port, it's going to go, that should never have happened, and it's actually going to turn the port off. So it's just, it's technologies that you can use to protect your network. And the minor thing is so you can set the BPDU, you can set the switch's spanning tree priority, and you can set spanning tree priority primary or secondary. And when you're setting it as primary, you might think it's setting it to a specific value. Maybe you might think it's setting it to 4096. That's not what it does. It actually just subtracts 4096 from whatever the current value is. So that's just a little thing to be aware of, I guess, more for when you're configuring an actual network. If you're trying to control the traffic, if you want to make sure a switch is always going to be there, you just set it to 4096, because then no switch can have a higher priority than that. Anyway, do you have any more questions? Did I create questions?
I'm typing feverishly, trying to keep up with questions and get stuff posted. No, I think we're mostly caught up. You should have some subnetting tips from Ray Olander in your email. He's been tweeting some out as well. But no other questions right now.
All right. Well, I could go longer, but I suspect that we're out of time.
We're only out of time when you are out of time and or sore throat. So if there's other things you want to cover, I'm happy to stay on and keep this going. But that is up to you. We could also pick it up on, we could try to get in another session as well, if you think there's more stuff to cover, if you've got other commitments that you need to get off for tonight.
Well, I mean, we certainly could go longer, but I don't have anything planned. And there's a ton of stuff that we could potentially talk about, but we'll gather up questions that people have, and then turn that into I'll turn that into a blog post, and if it warrants another session, then maybe we can work on that. But for now, fantastic. I think I've talked long enough.
That sounds good to me.
Unless people have questions, I'd be more than happy to try to clarify anything that I've said, or if you just have any general questions before we go.
I think that will do it for tonight, Scott.
Alrighty.
Folks that are on the line listening to the recording, please check out Scott's blog. What's that address again, Scott?
Mostlynetworks.com.
Mostlynetworks.com. Make sure you enter the contest for a chance to win networking for vSphere admins, or with a set of books, or a book for the CCNA.
It's actually the two-book library of, because the CCNA exam is, to get the CCNA, there's the ICND 1 and the ICND 2 exams, or you can take kind of a combined one, but it's the library with both books.
Excellent, fantastic. So make sure to get on there, and if you've got questions, get them onto Twitter. You can use the vBrownbag hashtag, or you can get Scott. I've got your Twitter address handy somewhere. Of course, not right in front of me. Scott M32768. What is 32768, by the way? Is that shareable, or?
No, that's the default priority for spanning tree.
Fantastic. I knew it was something network related. I just didn't know what.
Yep.
Cool. Yeah, so folks, get your questions out to us. Scott will write up a post, and as he said, if it warrants, maybe we'll get back on and we'll make Ed do some work next time.
Yeah.
Cool. Well, thank you very much for everything tonight, and we'll have this online shortly.